furanose and the beta D galactofuranose. Now what's the percentage? Alpha around 31%, beta around 64%. This is somehow 1 to 5%. It depends. Depends on temperature. So just tell you, it's very interesting. This scenario happens. Okay? That's what we talk about. Is another one we call it motor rotation. Okay. Next one. We want to talk about something else. What else we want to talk? Okay, we had a glucose. Let's come out with glucose formula again. OH, C, H, C, OH, C, H, OH, CH2, OH. A glucose in a closed vessel with nickel as a catalyst. So we're going through the very similar reaction when we talk about the fatty acids. It is also going through hydrogenation. Okay, when they're going through hydrogenation, what will happen? First of all, hydrogenation is you're adding proton, which means you're reduced. So what will be? What will be looks like? H. Okay, very simple. CH2OH. Then the others are exactly the same. Go here. These are exactly the same. The only is the aldehyde group they're going to change. From CHO becomes CH2OH. Then what is this called? Sorbitol become. Originally they call it a gluctol. So what is sorbitol? Sugar, alcohol. This is, we call it, can be used as a reduced sweetener for diabetic patient. Well, there's a debate about that, whether it is can be used or not. And so sorbitol looks like similar to sucrose. You also have acid. That is only 50% sweet than sucrose compared to the table sugar. Okay, so we have a sorbitol. Because we have a sorbitol, so we have other sugar alcohol. We have sorbitol, we have mannitol, so what else we have? Lysitol. We have the sugar alcohol comes out. Now what are they for? These kind of things used on the syrup. Okay, they could using as a subcomponents for the cough dropping medical stuff. Cough droppings could be using. And they could also using as a so-called a mint flavor. So they could use a non-chocolate mint chewy bar. They could add that. And they could also using as a less sugar candy bar coating. Okay, so this is from the nutrition standpoints or the manufacturing standpoints what they're useful. Now, what I learned about these, as a microbiologist, where I first heard about sorbitol, when I first heard about mannitol, this is the first thing we want to talk is sorbitol macanthi agar. So I want to talk a little bit here, because some of you are going to do the microbiology research. This is why first time heard about sorbitol. It's a macanthi agar, sorbitol macanthi agar. Because originally the macanthi agar has a lactose. So we call it a lactose macanthi. However, people think you are very smart. So they took lactose gum, become macanthi agar. The difference is the sugar is different. So why it is important? Because it could use to differentiate E. coli, O157H7, and non-O157 Shigella toxin generated E. coli. It is very important in my area. So what's the results looks like? Sorbitol macanthi. This is colorless. For E. coli O157H7, but macanthi agar is pink. How about non-O157 Shigella toxin generates E. coli? We call it non-O157 STEC. Sorbitol macanthi is a little bit purple to pink color. But non-O157 STEC on traditional macanthi agar, it is colorless. This is a very simple way to differentiate those two. Okay? That's something we want to mention. Okay, we want to mention another thing, also related to the microbiology. Okay, let's talk about this guy. This is a bacterial cell. From the beginning to the end, since you count WVU, you already know Freud mosaic model. We already mentioned lots of time. And we know this is a phospholipids. No question about it. We know phospholipids with protein as fluid mosaic model. And we already draw the structure of phospholipids since it's a food chemistry class. But we haven't talked about is what? If it's a gram-positive bacteria, what we haven't mentioned is this very heavy structure. And you should know peptidoglycan. Okay, what is the major components of a peptidoglycan? It is composed by, we call modified sugar crossing, linking or cross-linking with amino acids. And this is basically glycine and alanine. Now we're gonna not go there, but what are the modified sugar? Modified sugar, there is a one very interesting, is like a glucose. Almost similar to a glucose, but only one difference. What are the difference here? NH2, C, CH3. What is this one? N-glucosiamine. N-acetylglucosiamine, if it's a full name, okay? So we're going to say N-acetylglucosiamine. That's NAG. What are we missing here? We have another one we are missing. OH, H, We just draw beta. Okay, since our nature like beta. This is the same. Carbon number 2 are the same. CH3. Then you go here. H. This is R. Very interesting. We're going to do it. H, OH, H, H, CH2OH. And this typical order structure is O, C, CH3, H, and what is this? This is N-acetylmuramic acid. Acronym NAM. Okay, so that's why we say peptidoglycan by modified sugar is NAG, NAM. They are in a alternative arrangement. Now, of course, you have another lane is like this. NAG, NAM. So they connected with amino acids. This becomes peptidoglycan. Then these are the target for antimicrobials or antibiotics to do attacking. Now that's another topic. We could talk about another hour. So that's microbiology. Okay. Just these things we wanted to cover for you. So the last, before ending the class, we want to do a very simple conclusion. We talk about the isomer of the sugar. What we have, number 1, constitutional isomer. We have aldose versus ketones. Right there. Okay, we have glyceraldehyde versus dihydroxyacetone. Or the very simple, we will talk next week, is sucrose composed by glucose and fructose. Glucose and fructose are aldose versus ketones. It's a constitutional isomer. Second, enantiomer. What is that? That is D versus L. And our nature picks D. 99% are D. So that's an enantiomer. Okay, what are the 3? What are the third one? Epimer. What are the epimers difference? We mentioned about glucose and mannose, the difference at C2 position. And we also have is a glucose with galactose at C4 position. Okay, what's the last one? Anomer. Anomer relate to the anomeric carbon. We have beta and alpha. Beta is dominant, majority 64%, alpha is 36%. Very interesting, in the glucose we have a 5-carbon pyranose ring. Fructose will become a fructonase ring. Okay, so these are the things that become isomers. So this is what we have for the monosaccharides. We talk about all these interesting topics from the beginning to the end, especially the structure, from the Fischer configuration to Haworth and to the chair configuration. And we mentioned briefly about the sugar alcohol and something related to the microbiology. Okay, so Thursday we will talk about the vinegar manufacturing because we gave the opening remarks of the sugar. The next week we have 2 more classes. We'll talk about oligosaccharides and also the starch and the table sugar manufacturing. Then we hope in the last section we have a time to talk about the beer brewing because this is also talk about the polysaccharides which is coming from the starch. Okay, so that's all we have.